Hi everyone, welcome to my presentation. So today we're gonna see what's hidden behind closed doors and how to bypass RFID readers and physical access controls. But before we go to actually bypassing RFID readers, a little disclaimer. So we are gonna talk about access control systems security, and when we think about access control systems, we have to know that it's a big system that's made up of many parts, and we cannot only focus on one part. And here is an example of that. So, question for you, do you already see what's the problem with this door, or this little red arrow to help with that? Raise your hand if you know. Okay. And now, hint for others. Do you know what's that tool? Who knows that? Raise your hand. Okay, so we have some people. So the name of this tool is under door tool. And as the name suggests, we can use that to get under the door and open it. And here is a video of that. So as you can see, this is the video of the same door from both sides at the same time. I tried to open this, but there is no handle on my side. What I'm trying to do is I'm trying to get this under door tool underneath the door, and I will try to catch the handle on the other side. And as you can see on the right side of this door, on my side, there is an RFID reader. But I completely ignore it, because there are easier ways to get inside this place, in this case. And as a red teamer, I always try to find my way in the quickest and easiest possible way. And as you can see now, I managed to catch the handle, and I've let myself in, and I managed to break into my boss's backyard in this way. Very proud of myself, as you can see on the video. And yeah, who am I, actually? So my name is Julia Zduńczyk, and I work as an IT security specialist at Securing, where I conduct penetration tests of a variety of IT solutions. And I'm a red teamer, so I do those physical tests. But my true passion is finding new ways to get adrenaline rush, either by trying different sports like horse archery that you can see on the picture, or by breaking into different server rooms that I shouldn't get access to. But sometimes I manage to let myself in. And today I'm going to show you different ways in which you can break into buildings. So during this presentation, we will talk about RFID, which stands for radio frequency identification. And it's used in access control systems like access tags and access readers. But it's also used in many other places. Actually, it's everywhere around us. So we can meet RFID for cloud tracking, for contactless payments, for those access control systems, in some more interesting places as well. So now we'll switch to my camera, to my setup that I have right here. So I have some interesting RFID things too. For example, RFID button that can be used to track linen, and there is actually RFID tag inside. There are some stickers, so as you can see, it can be pretty small and it can be hidden in many places, or those hospital tags. I also have a RFID syringe at home, but you can travel with syringes in your luggage, so I didn't take this with me to not risk it. There are also other interesting uses. Right here on the left picture, you see a coffee filter. And this coffee filter has an RFID tag inside. Why? To stop you from buying unoriginal coffee filters. So that's what the producers can do. That's one of the evil uses of the technology. And on the right side, we see a road sign that apparently got stolen pretty often. So often that they had to install RFID tracking inside, whatever that would mean. I don't know why it would be stolen, though. And if you heard about RFID, you probably heard about card cloning. Maybe even you tried it yourself. But the thing with card cloning is that sometimes it works. For example, if we operate with a low security system like POX card, which is a low frequency card without any encryption. Or when employees don't take care of their cards and they leave them unattended. For example, here is a photo of a card left on a table during a lunch break. That was very accessible. But sometimes RFID card cloning doesn't work that easily. For example, if the system is pretty secure, like CEO's card with elite non-default keys, it will be very hard for us as a red teamers to actually clone such a card during engagement. It would take a lot of resources and time. And In some cases, we'll get lucky, like here, where someone left the card permanently attached to the reader. I guess it was very convenient for the employees of this company. For me, it was very funny when I saw this for the first time. But we won't always get so lucky. And it got me thinking, what are other ways in which we can bypass RFID access control systems without actual card cloning? And for this part of the presentation, I will divide access control system into two models on which they operate. So first one will be autonomous RFID locks. In this case, we will have a door, which is a barrier between secure and unsecure area. And next to the door, we'll have a reader. The reader will communicate with tags over radio frequency. That's what the dashed line is for. And in case of autonomous RFID locks, the reader is the brain of the operation. So it decides if it will open or close the door. It has, in simplification, the list of valid IDs for this particular door. And as soon as it gets the ID, it will make the decision to either open or not open the door. And how this system works. So I have an example of such a system with me here on stage. I will show you in a second. And basically, for my reader, you can add cards in two ways. First one is using a specific manager add card. And we can see how it works right now. So here I have such a reader. It's this one, Seburi reader. And we can see that it operates with MIFARE cards. You can observe the LED. Do you see if it lights up? Yeah, it's green right now, and now it went off. So this card is valid, and it would open the reader, the door that the reader is connected to. And we can delete this card from the system. So we will use the delete card. Now we are in the deleting mode. We'll put the MIFARE card again and get out of the deleting mode. And now the card no longer opens the door. So that's pretty simple. And another way to add or delete cards from the system is to use administrator setting that you can enter entering a specific PIN code. And first thing you can look for if you're trying to break such a system is just check for the manual, because oftentimes the default PIN code is left. And so actually, many times it happened that you can just go to this reader, check the manual, enter the code at your own card, and now you have access. But that's pretty simple, right? It's not very interesting. And there are more interesting vulnerabilities connected to those autonomous RFID locks. The second one would be logic bypass of the lock operation. And by that, I mean a card that would always open the lock, even if we try to delete it from the system. And now it will be a little exercise for you to think about such a card. So here is an example of how the ID of the card looks like. In case of MIFARE cards, the ID is 4 bytes, hexadecimal. Here's an example of one of the IDs. And do you have any ideas which ID would be so specific to always open the lock? Raise your hands if you have any ideas. I have one there. All Fs. Okay, we may try that. So actually, that's a good answer, and I have such a card with me today. So it went pretty quickly. Normally we try different IDs, but you had a good idea. So yeah, I have a card that's ID is all Fs, and now I will put it close to the reader. It opened, right? But you may say that I already added this card before the presentation, so we will try to delete it from the system. So once again, we're entering the deleting mode. We are trying to delete the card. And now it still opens the lock. There is no way to get rid of this card. And why this may happen? So the idea is that maybe if the lock holds a list of valid cards and someone added some card and then deleted it, instead of being deleted from the list, the ID gets changed to all Fs. Maybe that's the default value. That's my idea, but maybe there may be other ideas. Maybe someone just left this card like a backdoor or something. I'm not sure, but when you find a reader like that in the wild, what you can try to do is you can get a card with all Fs ID and try to open it, and maybe it will work out. So that's one of the interesting vulnerabilities. Other thing that may go wrong is EMP generator, electromagnetic pulse generator. Who heard about that before? Okay, so basically that's a device that generates a very strong electromagnetic pulse that may do strange things to hardware, basically. So in some cases, it may reset the memory of the hardware or do some other things. And with locks like that, it actually can sometimes open them. And here is a video of that. So that's the Saber lock. It's not the exact same that I have on the stage, and I will tell you in a second why. But it's the same model. And I'm putting the electromagnetic pulse generator, and as you can see, it opens the lock instantly. The thing with, and there is another video from the sellers of this thing that you can buy on AliExpress, by the way, opening different locks in the wild. The thing with electromagnetic pulse generator, though, is that it's quite unreliable and it can fry locks. So that's why I no longer do a live demo of that, because first I lost one of the readers because it got treated with this pulse generator one too many times. And second, once I tried to do this live on stage and it did strange things to audio setup, and I don't want to break that for next presenters. So yeah, video will be fine this time. Other things that may go wrong. Actually, there is many problems with those readers, too many to talk about all of them today. For example, as you remember, the reader decides to open the door or not. And basically that means that in most cases there will be two wires going from the reader to the physical door lock. And if you get access to this wire, you sometimes can just cut them and it will open the circuit and it will open the door. So basically, all the logic of the operation of these locks happens on the side that you have access to, right? Because you have access to the reader, you can take it off the wall, whatever. And also, if you want to get access to some area, if you're desperate enough, you will find your way in. So you may try anything, especially if you tried to use the EMP generator and now the lock no longer works. That might be the only way to get inside in that case. So yeah, autonomous RFID locks are not very good, and we will mostly meet them in low security areas like apartment buildings or flats or entrances to staircases. But when we go into actual organization, we'll meet a slightly different system that consists of more parts. In this case, we will also have a door that's a barrier between secure and unsecure area. And we'll have a reader that communicates with tags over radio frequency. So far, everything looks exactly the same. But in this case, the reader won't make decision itself. As soon it will perform any form of authentication between the reader and the card. It will perform decryption of the card ID. But as soon as it gets the information from the card, it will send it further to a controller over wires hidden somewhere in the wall. And the controller, in simplification, will make decisions and check the ID with the list and either open or not open the door. And for the later part of the presentation, we'll focus on this red line, which is the communication channel between the reader and the controller. And in most cases, we will meet a protocol called Wiegand here. So basically, Wiegand is a very old protocol, and its operation is pretty simple. We'll have two wires getting out of the back of the reader. In most cases, it will be white and green wire. And basically, two wires are in high state, and whenever one of them drops low for a specific period of time, the bit of information will be sent. 1 bit on white wire and 0 bits on green wire. But the biggest problem with Wiegand is that there is no encryption at all. And this means that as soon as the reader gets the decrypted ID of the card, it throws all the security of the window and just sends it in an unencrypted form to the controller. So no matter how complicated the encryption algorithm is used between the reader and the card, it doesn't matter because later it gets sent in an unencrypted form. And of course, we can leverage that as a red teamers. So now we'll do a little red teaming exercise and we'll try to act as a red teamers. So let's say I got tasked with a red teaming assessment. And what I would do to bypass RFID system in a specific facility. First of all, of course, I would check what technology are we working with. Because I may use the Wiegand attack. I may try to clone the cards. There are many different ways to achieve my goal. So in this specific case that we'll be working on today, I managed to get a very high quality photo of an employee card. And it's very easy to learn what type of technology I'm working with because it says it on the card. It's a CO's card. And what do we know about CO's cards? Well, they are pretty hard or expensive to clone without specific equipment and pretty advanced knowledge. It takes some time. You have to get access to the card to decrypt the data from it because the real credential is encrypted inside the card. So in case of a real-life red team engagements, it would be pretty inefficient for us to try to clone these cards. But we can leverage our knowledge about Wiegand. And if it's used in the facility, we can completely pass the part with the encryption and try to get access to the decrypted data directly. So what we'll do now? Actually, those attacks on Wiegands are not new. So we have some equipment that we can use to attack the Wiegand protocol. For example, ESP key or Bluetooth Low Energy key. There is also a new tool created by my colleague, Jakub Kramasz, that's called the TIC. And we will try to see this device in action today. So what we'll do, we'll get this device and we'll try to install it on the wires behind the RFID reader, and we'll try to intercept the communication that happens via the Wiegand protocol. So now let's switch to the camera and see how it works. So I have a little access control system setup with me here today. So here you can see we have a door, we have a lock, and we have a reader. And behind all of that, there is a Raspberry Pi and a lot of wires and tape to hold all of that together. The Raspberry Pi acts as a controller. There is basically some Python code running on it. And now we want to get access to the wires, right? To install the device, to get access to the Wiegand communication. So our first step will be to take the reader off the wall. Normally there would be a screw underneath the reader. I already unscrew it to make it quicker. So let's just do that. Let's take the reader off the wall. Oh, do you hear that? Well, that's not good. That's actually an alarm. So in that case, we could get caught, right? We can just go to the reader blindly trying to take it off the wall. In this case, we have a little sensor right here. Oh, sorry, right here, that detects if there is any light. And in this case, I can very easily disarm this alarm by getting access to the wires. I'll try to show it too. Oh yeah, now it should be better. So in this case, there are just these two wires connected together, and when I untangle them, the alarm should be disarmed. So that was not that hard, right? So yeah, let's talk a little bit about alarms. Okay, so these are called anti-tamper mechanisms, and they can work in different ways. In this case, it was just a light sensor. But it may be, for example, a physical spring that touches the backplate of the reader, and if it gets disconnected, it opens the circuit, and then the tamper alarms gets triggered. And in most cases, it will work in a way that there will be a wire getting out of the reader. In this case, it was one of the wires that I untangled. And it's either in high or low state, and when it changes states, that sends the information that the alarm was triggered. In this case, I connected the tamper alarm with beeper, so it triggered the beeper. And well, we have to take this into account when we try to attack RFID readers, that we may get caught. But if I'm going to be honest, in most cases, when you buy this reader and you connect it with your system to make the cards work, why would you bother connecting it at the tamper mechanism, right? That's another part of the system, and who would bother with that? You already have a lot of work connecting everything together for the cards to work. So yeah, in most cases, this wire won't be connected to anything. So, and even if it is connected, it may be just a beeper alarm, like in this case. That's easily disarmed. Of course, there are some systems that are configured well, and this alarm will go to some log system and alert security guards when someone takes the reader off the wall, and it should work in this way. So yeah, we should always take that into account when we try to attack this reader. Okay, but let's say in this case I was lucky and there was no one around me, there were no security guards and no one saw me getting access to this reader. So I can continue with my assessment. So let's go back to my reader. And now, as you can see, we have access to the wires. In this case, 4 wires are connected. And as I mentioned, green and white wires for the Wiegand. And then we have power wires. So now we will take our device, the TIC, which has these connectors, and we will try to put it on the wires. Now, let's see how long it takes me, because it needs some precision, but we'll try to do this live. So basically, I'm putting the white wire, and now I'm putting the green wire for the 0 bits too. Okay, it got connected. And now I will put the power wires inside. So, as you can see, we don't have to actually cut the wires. It only cuts the isolation and get access to the core.
Basically vampire taps.
Yeah. Okay. I hope I connected it right and didn't switch the ground and power wires, but I think there is a protection from that. Okay, and we can see that the device works because there are some LEDs blinking. So now, during red team assessment, of course, I would like to hide it in the wall again to start collecting the information. So we'll put it back inside. Now, in this case, I use these connectors that are pretty big, but there are also options to make it a little bit slower, little bit. Yeah, thanks. Okay, and now we have this in the wall again. And now we can start collecting information. So let's say that now I'm hidden somewhere and waiting for employees to tap their card and provide us with some information. So let's say I was waiting, and finally some employees came and they authenticated to the reader, opened the door, and got inside. And let's say it happened a few times just to make sure that I will get the data. Now I can connect to my device via Wi-Fi and get access to the interface. And as we can see here, I got some data. We can try to, I got some data, so we can actually see some taps that were made with the card. And we also get some gibberish data, of course, because it happens. But what is of interest of us is this number right here, which is the card ID. And I mentioned earlier that the CEO's cards that are used in this facility, the ID of them is encrypted inside the card. Here we have the decrypted value. What we can do with that? We can actually use that. And because we have the device on the wires and the device can send information over the wires too, we can now remotely open the lock. Yeah, so now I don't need any card, I don't need anything. I can just go to the door whenever I want with the device behind it and just open it remotely or do it for my friends that are inside. So yeah, success. We managed to perform our engagement. Well, not actually, because even though now I have access to this reader, as you can imagine, there is a lot of doors in this facility, and that would be pretty inefficient if I were to go around and install this device on every reader. It would take much time, much equipment, and probably finally someone would caught me, right? But maybe there is another way to get access to other readers and to be able to open all the doors. So at the beginning of the presentation, I talked about card cloning. And I told you that it's very inefficient to clone CEO's card because we would have to have the encryption keys. And that's right. Real ID is encrypted inside the card. We all know that now I have the decrypted ID, but it's still not that good for me because I still need the encryption keys to be able to encrypt this ID to make a clone of the card, right? So it can communicate with the reader and perform the decryption procedure and everything. But maybe there is another way to use this decrypted ID that I got. Maybe someone left some legacy settings turned on for this reader that will allow me to run some different attacks. So let's try to learn something more about this reader. Maybe I will get some more information that will help me. So one thing about RFID, in most cases, actually in access control systems, it will operate on two different frequencies, either low frequency or high frequency. The COS card operates on high frequency. But sometimes readers can operate with more than one type of card. They can accept other cards as well. So what I can do, I can try to see if this reader operates with different frequency. That would give me an information that maybe there are more cards that it works with. For this, I have this little device. It's called RF field detector. And then when I put it close to the reader, the LED lights up. The higher one is for high frequency, and the lower one is for low frequency. And this way, I can see that this reader operates with both. And that means there are probably other types of card that it communicates with as well. So now I can take a bunch of cards and try different ones to see if any of them will work with this reader. We can try MIFAR. This is actually a high-frequency card, but it does nothing. So the reader will not communicate with this card. But we can actually try this one. And as you can see, the reader beeped and it light up. This is a prox card. It's a low-frequency card. And now we know that this reader speaks with this system. And it's actually a very good information for us. So let's talk about those type of cards. COS card, that is used in the facility. We already know this one. It's not easy to clone. But prox card, on the other hand, there is no encryption at all on this card. So basically, the ID that is written to this card is being read by the reader in the exact form that it was written. There is no decryption procedure happening. So what we can do now, we can try to run something called downgrade attack. For this to work, and it's not only with prox cards or COS card, it can work with other types of cards as well. For this card, we have to have for this attack, we have to have a system that has some legacy settings turned on. So even if it operates with high security cards, it can communicate with lower security cards as well. And the idea is to obtain the decrypted ID of the high security card, like we did with COS, and then put this decrypted ID on the low security card, because it will be read in the exact format that it was, that we got. So we'll try to do that right now. We'll switch to camera once again. And for that, I have another device. It's called Proxmark. I guess some of you heard about it. So basically, it's a device that allows us to communicate with RFID cards and, for example, change ID of the card or do other things as well. What we'll do now, we will get the decrypted ID of the COS card from here, and we will try to put it on the prox card that we got here. I think that's this command. Okay, we can see if it worked. So basically what I did, I took this card that we saw earlier that didn't open the door, but it communicated with the reader. And now I changed the ID of this card to the one we got from the COS card. And we can actually see that it's the exact ID. So now we'll try to use this card to open the door. And it opened. So now I have a clone of the COS card. It's not actually a COS card, but from the perspective of the controller that gets the information via the Wiegand wire, it will be exactly the same card. It doesn't know what type of card it is. So what I can do now, I can walk around the whole facility, opening different readers with this card without having to put the TIG device behind the wires. So I'm in a much better situation as a red teamer right now. And that's great. We managed to get access to the facility. We happily made our engagement. And now we can go around and open all the doors. And at this point, it may seem not good for us, because we bought this very expensive system with COS cards. We did everything right. We don't have any bad encryption. We don't have default keys, and we thought we are safe. But now attackers can go and just take our readers off the wall and still get access to the decrypted data from our cards, right? Well, of course, there are other solutions than Wiegand, which is very old, and we'll talk briefly about them. So other solution that we may meet in the wild is called Open Supervised Device Protocol, OSDP. And the good thing about it is that it supports AES encryption. So no longer unencrypted data being sent over the wires in our facility. Though there are some problems with that as well, as you can imagine. So take a look at the supports AES encryption part. It only supports it when secure mode of operation is used. So, of course, when you buy the system, you have to configure it well. And as you can imagine, some people leave it without any encryption. So even if we meet system with OSDP, we can still try to put some device on the wires and listen to the communication. There is also more interesting attacks about OSDP. I don't have time to go through all of them right now, but there is an interesting DEFCON talk, Batch of Shame, and that talks more about this problem. For example, one of the attacks you can run on OSDP, even if the encryption is turned on, you may put a device on the wire and then act as an alt reader and send information to the controller that I'm an alt reader and I do not support encryption, so please turn off encryption for me. And if it's not configured well, it will do that. So we'll go back to the beginning with no encryption at all. And yeah, everything cool. You saw the attack, but you also saw that it takes some time, right? And I have to get access to this reader, take it off the wall, install the device, put it back again. Sometimes it takes a few minutes. Maybe there are cameras in the buildings. It's not that easy to do. And when we go into actual red team assessment, how can we actually do that? And of course, we could try social engineering, and I guess everyone heard stories that you can get everywhere with a ladder. And actually, it's true. So this is me during one of red team engagement. As you can see, I have a very professional disguise. I acted as a server room technician. And the story is that I actually managed to get through reception desk and tell the story that I'm a server room technician. So yeah, I got access inside. To be honest, later I was caught during this particular engagement, but it was due to other reasons. That's pretty long story, so if you're interested, you can ask me after the presentation about that. But yes, you can get inside with social engineering and professional disguises, but in reality, you don't need to act as a server room technician. In most cases, all you need to get inside is a lot of confidence. And this is an interesting recording from one of red teams. So on this recording, I'm trying to open a server room with a plastic card. Let's take a look at that. It took me a few seconds and a few tries. And yeah, I managed to get access to this server room in the end. Once again, very happy with myself. But the clue of this video is that I did this in the middle of the day in a very busy office. Like there were employees walking around while I was trying to open the server room with a plastic card. And no one went for security guards. And this was due to the fact that I was very confident. I was smiling. I was talking with my friend who actually was another red teamer who went there with me. But because we acted with a lot of confidence and like we belonged, no one paid attention to us. Like, of course, they were looking at us strangely and wondering what we are doing, but no one asked us, what are we doing here, who we are. So yeah, in most cases, all you need is a lot of confidence. And, well, right now I can, during my red team assessment, I have a clone of a card. I can walk around the building. I can open server room doors with plastic cards or hangers, which also happened once. What if I told you that I can also stop you from using your own readers? So yeah, that is another attack that it's very useful during red team engagements, basically denial of service on readers. So let's imagine a situation that I managed to run all those attacks that I showed you, and now I have access to server room with a card. So I got inside, and now I want to spend there like half an hour installing my Raspberry Pi and getting access to the network. But I don't want to get caught. I don't want anyone going inside while I'm there, because that would be pretty suspicious, and probably I wouldn't find a good story to get out of that situation. What I can do is I can get inside and then put the reader on the server room entrance into a non-working state. And how can I do that? First idea is to do that with the tick. So actually we have a DOS mode with tick that when it's installed on the wires, it can basically flood the wires with some rubbish data and no useful data will get through. And let's do that. So basically in tick we have the DOS mode. And if it worked, this is the original card, the CEO's card that the employee used to get inside. And it no longer opens the door. Let's try the card that I prepared earlier, that I cloned, the prox card. It also doesn't open the door. No card will open the door right now. No one can get access inside. So I can do whatever I want inside the server room for as long as I need. And then when there is no one outside, I just can go out and escape from the building and have everything for my assessment ready. There is also another way in which we can perform denial of service attack. So specifically with HID readers, like the one I have here with me, in some cases they support Bluetooth, and you can connect to them via HID Reader Manager app that you can download for your phone, and that's free, and you can set up a free account on it. And if the reader is unpatched, and of course many readers are unpatched, you can actually perform denial of service, which is kind of a feature in this app. So basically, when we use HID Reader Manager app, we can detect readers in the area that are seen by the Bluetooth. And when we choose a specific reader, we can perform two operations on that, either inspect or locate. In inspect mode, the reader will blink for 8 seconds. And for this 8 seconds, while the inspection is happening, it won't accept any cards. What we can do, we can put this inspect mode in a loop, and no one will be able to authenticate to this reader and will be just blinking and not accepting any cards. And another thing we can do that is pretty interesting is the locate mode. So it looks pretty similar. It works pretty similar to the inspect mode. In this state, the reader will also blink for 8 seconds. It won't accept any cards, but it will also beep. And we could try to use that as a decoy, right, during our assessment. So let's say I was doing one thing in one part of the facility. So I don't know, I was trying to get access to laptop of one of the employees or was trying to connect to some Ethernet ports. And I don't want employees walking around, and I don't want security guards walking around this part of the building. What I can do is I can scan for all the readers in other part of the building and then put all of them on the loop in the locate mode. What will happen? All of the readers will start beeping loudly. They won't authenticate any employees, and now you have a lot of chaos in your facility with beeping readers. No one can get anywhere, no one can get their job done, and I'm in the other part of the facility doing my thing. So that's one of the interesting attacks. And how can we secure ourselves from these kinds of attacks? Maybe that's a question for you. Do you have any ideas what we can do to protect ourselves? Configure them. Yeah, that's actually the best advice. Exactly, yeah, I love that answer. Yes, configure your readers correctly. So when you buy those expensive readers that do have encryption implemented, check all the settings, check that you connected it correctly, that you turned on all the security settings. Other ideas based on the presentation, maybe? Work from home, yeah, I love that. Yeah, I mean, yes, that would save us from all the problems with RFID. That would probably introduce some more problems that are completely different, but yeah, that's one of the ideas. Yeah, we can actually try to do a lot of things, and going through all the presentation from the beginning. First of all, always place controllers in secure areas. So when we talked about the first example of those autonomous RFID locks, the lock was the decision-making unit. There wasn't actually the reader was the decision-making unit. There wasn't actually a controller, but we may say the controller was integrated with the reader. and it was on our side. So we were able to cut the wires, we were able to treat it with electromagnetic pulse generator. You always want to have this system that has a separate controller that is placed somewhere in secure area in the building. Another thing is more advanced solutions. So don't use Wiegand that has no encryption at all. Use OSDP or other system that supports encryption and is good. But exactly, configure these things properly. Turn on the secure mode. Don't leave any default keys for the encryption. Another thing is proper tamper detection. So do not connect only beeper like I did. Connect these wires to some system that collects logs and gives information to security guard instantly to come and check why someone is taking reader of the wall. Keep reader firmware up to date. So do not leave those HID readers with this Bluetooth mode that you can perform denial of service attacks on them. Disable legacy credentials so that we cannot make clones of secure cards using less secure cards. These legacy credentials, in most cases, they are turned on in facilities that used to use low security system. They switched to higher security system, but they want the employees that already have those low security cards to also have access to the system. But that's not a good idea. Just switch fully to the more secure system. And many, many other ways, as always with the system. As I said at the beginning of the presentation, you always have to take into account all parts of the system, not only RFID. So always know that there will be someone who will try to find a new way in. And who sees a problem with this picture? I know there is a glass door, but that's not the biggest problem. Let's take a look not at the door, but at this wall here. You may actually notice a little gap between this wall and the ceiling when the pipes run. So yeah, that's me. You maybe remember at the start of the presentation, I told you I like to do a lot of sports. One of them is climbing. One of them is cave exploring, so I'm used to squeezing into tight spaces. And I can sometimes use these skills during red team engagements, which is always pretty funny. So yeah, this is me trying to get into this office because we weren't able to clone the cards that day. And yeah, it worked. And I'm still alive, so, you know, it wasn't that bad. I managed to get down on the other side. Yeah, so key takeaways from this presentation. Physical access control systems are oftentimes insecure. We still meet those systems with Wiegand, which is like decades old. So take that into account, especially when you use those systems at your facility or you leave your valuables in a hotel room. I can tell you most of the times they are not very secure systems in hotels. Physical red teaming, which is the thing I do, is a service designed to check for these vulnerabilities because otherwise, oftentimes, it's hard to check for them. You have to have a physical red teaming team on place to check those readers, check what types of wires are behind them. And these vulnerabilities are oftentimes overlooked because in most cases, clients want web application pen tests or infrastructure pen tests that's easy to do with a remote team. These kinds of tests happen way more rarely, but they are also very important, and we can find very severe vulnerabilities via physical red teaming. And the last thing, raise awareness, educate, and learn. As you saw, there is a lot of vulnerabilities in the system. They are still used now. Many people don't know about them, and we get this card at the hotel, and we are sure everything is right. So always try to learn more about that and ways to protect yourself. And that will be all from me for today. So special thanks to everyone who helped me with this presentation. Sławomir Jacek, who prepares great trainings about RFID. Jakub Kramasz, who created the TIC. Maciej Miąskowski, who is my great supporter. My dad, because actually he helped me with the setup. When you look at that, so it was my first time using woodcutter. And you can see this straight line here that he did, and this line here that I try to do, but I still have all my fingers intact, so I'll call it a success. And yeah, big thanks to everyone who puts their time and effort into physical access control systems research. It's a very interesting field with a lot of things to discover. And yeah, I really recommend looking into that. So thank you very much.